Module 3 is about systems of equations, and we're going to start by graphing because that is what we did in the last module. And so really, a system of equations is just more than one equation, two or more equations that we think of together in the same context. So we graph them on the same coordinate plane. So if you look at number 1 on this sheet, and I'll zoom in so we can see that a bit closer, you're going to graph each of these two lines on this coordinate plane and look at what points the two lines have in common. So in graphing this first equation right here, I need a slope and a point. And remember, this is in slope-intercept form. And so hopefully you're seeing the coefficient of x, that 4, has to do with our slope. And I like to put a little 1 underneath there. That's our m. So we're going to go up 4 over 1. But where do we go up 4 over 1 from? That leads us to this part right here, which is our b. This is our point. So we're going to plot that at the point 0, 3, because it's our y-intercept. And this is our y-axis right here. We go to 3. From there, we go up 1, 2, 3, 4 over 1 and put our point. We could also go down 1, 2, 3, 4, and then we'd have to go left 1. And you can see that these all fall in a line. Use a straight edge to connect your points like I did. And then let's take a look at this second line that we have here. So y equals negative x minus 2. Again, we look at our slope and our point. When I have a negative in front of x, I want to put a little 1 there, at least imagine that. That's going to be negative 1 over 1 for our slope. But we need to know our starting point first, and that, again, is the constant being added or subtracted to our x. We have negative 2, so that means we're going to start at the point 0, negative 2, which is right here on the y-axis because that's our y-intercept. From there, we can go down 1 over 1, and we can keep going down 1 over 1. We can also go up 1 over 1. You can see I hit right at an exact point right here, and that's what you should see everywhere on this page. This point right here, has an ordered pair of negative 1, negative 1. And so that is our point of intersection that we're going to plot right here. And I'm also going to connect my points, my red points here, with a line. So this system of equations right here, we plotted the top one in blue, and that had a positive slope. We plotted the bottom one in red that had a negative slope. It intersected right here at the point negative 1, negative 1. This right here, negative 1, negative 1, is our solution to this system. You are going to do that for the rest of this page. Everything on this page is in slope-intercept form, except for number 6. We have our special cases there. Remember, when it's just x equals or y equals, those are horizontal or vertical lines, and you know how to plot those. You can look back in your notes if needed. If you flip to the second page, you will see some review of just graphing lines, but they're not necessarily in slope-intercept form. We have to figure that out. For the ones that are not in slope-intercept form but are in point-slope form, like number 9, you know the point. You don't have to do anything to that. You can just graph it in that way. So I'm going to zoom in to number 9. So look at that one. So I can see my slope here is the coefficient of x. I have just a negative. That's the same as negative 1 over 1. And I have a point that I'm looking at right here. And remember, for the x, we take the opposite. So in my equation, it's x minus 4. So that means it's a positive 4 in my ordered pair. And outside of my parentheses, the y value, the plus 2, stays a positive 2. And so I would plot that by going over 4 up 2. And so I have a point right here. And from that point, I'm going to use my slope, and I'm either going down 1, right 1, and keep going down 1, right 1, or I can go up 1, but I'd have to go to left 1 to stay following that negative slope line. And you would just connect that with a straight edge. So if I go zoom back out, a question like number 7, you have to do what we've been doing to solve and get y by itself. So I see something being added or subtracted. I would need to subtract 3x from both sides. And then from there, I'm close. So, and remember, these are not like terms, so they cannot be combined. So after I simplify this, I'd have negative y equals negative 3x plus y, because these right here were not like terms. But I have negative y still, and I need to get rid of that. So I could divide everything through by -1, and I would have y equals positive 3x and then -3. And again, slope, I like to put a 1 underneath that, and my starting point is this value right here, the -3. So I need to start on the y-axis at 0, -3, which is down here. And my slope is up 3 over 1, up 3 over 1. And again, if you want to go down, if you need to for some reason, that's fine. You just are going to have to go left 1 to keep it in line with our dots there. And again, sketch those lines out. Use the straight edge, because the line is every dot along this path, not just the nice ones that hit at the grid marks. And finish the rest of both sides.